Alright, let's look at the last question, which is still under Euclidean geometry in grade 10. We are given that PQ is parallel to SR and PS is parallel to QR, and also that PS is equal to PQ is equal to QR is equal to SR. That definitely you should know that this is a rhombus. Okay, so what would be the question if we are given everything? We know it's a rhombus, and we know the properties of a rhombus, that diagonals bisect each other, diagonals bisect at right angles. So what does the examiner want? So the examiner wants us to prove that PO is equal to OR and SO is equal to OQ. So should we tell the examiner that we know that these are the properties? One thing you need to understand is that they are proofs of theorems. The effects that have been established here, they were established after a proof. So the examiner is saying, show that this SO is equal to OQ, PO is equal to, using a proof, not the knowledge that you have about the rhombus. So under proofs, you have to you can take triangle POS and triangle QOR, or POQ and triangle SOR, and prove congruence there. So let's say we take, that is for 9.1, in triangle POS and triangle QOR. The order is not important when you are establishing the triangles, but when you conclude, it's very, very important. So we have started with triangle POS, so we'll state the effects on this triangle, relate them to the other triangle. Alright? So we know that PS, we are given that PS is equal to QR, we can start there. Also remember, you are proving congruence. And when you are proving congruence, you can either go for side, 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 angle, side, angle, angle, side, then RHS. Those are the four conditions that you can adopt when proving congruence. Alright, so PS is equal to QR. As simple as it is, it's given. We cannot use the sides that we have been asked to prove to say SO is equal to OS. They have said prove that. So it means you cannot use in proving congruence. Use some other effects that are given. Now we do have parallel lines here. That means we can say angle P2 is alternating with angle R2. So angle P2 is equal to angle R2. These are alternate angles. And we state the parallel lines. PS is parallel to QR. Alright? Then we can also say angle O2 and angle O4. These are vertically opposite. Angles. If you don't want to use these two angles which are vertically opposite, you can as well use angle S1 here, you can use angle S1 is equal to angle Q2. These are alternate angles. State the parallel lines. It's a PS is parallel to QR. One thing that you should not do is to take the three angles, because under congruence we don't have a proof of congruence which talks about the three angles. It's under similarity. So you have a side and the two angles. So you can conclude that. So we are saying therefore triangle POS is congruent to triangle. Now the order is very, very important. When you are at P, where are you in triangle QOS? When you are at P, you'll be at R. Remember, angle P2 is equal to angle R2. So the positioning P corresponds to R. And then when you go to O, you will be also coming to O in the other triangle. And then when you go to S, definitely you'll be going to Q. And don't forget to state the reason why you have said these two triangles are congruent. That is angle, side. Now, it is from this that we can now establish the sides that are equal. So we are saying therefore PO is equal to RO. PO is equal to ORO. We can also establish that OS is equal to OQ. Of course, PS, we have it here. PS is equal to RQ. So we don't need, the examiner wanted us to establish this. Alright, so basically that's how we answer 9.1. Now 9.2, you are asked to prove that diagonals bisect at right angle. Now, if diagonals bisect at right angles, it means that we have to prove that we do have right angles here. So to do that, we have to take two adjacent triangles. We can take